Why is anti-gravity research so hard to fund? Imagine trying to build a machine that makes objects flow or hover without any visible support. Sounds like science fiction, right? Well, that's the challenge with anti-gravity devices. They are part of cosmic curiosities and scientific oddities that spark the imagination. But turning these wild ideas into real, working inventions is a different story. The main reason anti-gravity research struggles to get funding is because it's seen as highly speculative. There's no solid scientific proof that anti-gravity is even possible. The idea involves controlling or neutralizing gravity, which is one of the four fundamental forces of nature. Gravity is explained by Einstein's theory of general relativity as the curvature of spacetime caused by mass and energy. But this theory doesn't tell us how to block or manipulate gravity directly. That leaves anti-gravity ideas floating in the realm of theories without firm backing. Without clear experimental results or reproducible experiments, most scientific organizations stay cautious. Many proposals relying on concepts like negative mass or exotic matter, which are hypothetical and have never been observed. These ideas sound fascinating but lack concrete evidence. When experiments fail to produce consistent anti-gravity effects, critics often dismiss them as pseudoscience. This skepticism makes it hard for researchers to get serious funding. Another hurdle is the enormous energy needed. Some models suggest that creating anti-gravity effects would require energy levels far beyond what current technology can handle. Developing exotic materials that could support anti-gravity effects is also costly and uncertain. Funding agencies prefer projects with predictable costs and clear outcomes, which anti-gravity research does not yet provide. Institutional resistance is also a factor. Anti-gravity challenges well-established physics principles, so many scientists and institutions see it as fringe science. They prioritize research with proven theories and practical applications. This makes anti-gravity projects seem too risky or unlikely to succeed. On top of that, some military and government agencies have secretly explored anti-gravity or related propulsion systems for decades. These efforts are often classified, so the public and scientific community don't get full access to their findings. This secrecy limits open collaboration and makes it harder for mainstream scientists to get involved or fund such research openly. Finally, without proven prototypes or clear paths to useful applications, commercial investors hesitate. The potential benefits like revolutionary propulsion or weight reduction are still theoretical. Until someone develops a working anti-gravity device or demonstrates consistent results, funding remains scarce. It's interesting to note that some eccentric inventions and scientific oddities have tried to push the boundaries of anti-gravity ideas. While the dream of defying gravity fuels curiosity, turning those dreams into credible science faces many obstacles. Despite the challenges, the fascination with anti-gravity continues to inspire inventors and explorers. They keep imagining what might be possible someday, even if the current scientific landscape makes funding a tough climb.